In 9.9, we're going to be looking at power series. So we want to find a series such that when we add our series together, we get 4 over 3x plus 2. So we're going to have some sequence, and our sequence is going to have a variable, so we could call it u sub n instead of a sub n. And when we add all of the infinite amount of terms together, we want them to be equivalent to 4 over 3x plus 2. Now recall that for a geometric series, if a geometric series converges, and when does it converge? It converges when the absolute value of r is less than 1. Then that series converges to a over 1 minus r, which kind of resembles our fraction. So when we sum this series, our answer is this fraction. So if we sum our series, and we want that series to add up to be 4 over 3x plus 2, and since it's geometric, that's going to be a over 1 minus r. So since we have this relationship, we need to find out what a and r would make these two things equal. How can we get a and r such that this fraction is going to be what we total when we sum a times r to the n all the way to infinity? So the trick is going to be to rewrite this in this format, and we are centered at 3, at x equals 3, meaning that's the center of our interval of convergence. So to make these look alike, we have to notice that on bottom we have a 1 minus some stuff. 1 is a constant, so it would help us if we started by putting our constant first and then our other term. If it is centered at 3, then from x we have to subtract 3, like so. Notice I put the x in parentheses with the minus 3 so that 3 is subtracted directly from x, not from the product of 3 times x. So this makes our center located here. Well, we can't just simply throw a minus 3 in here. If we put a minus 3 here, we've really subtracted 9 on bottom. 3 times negative 3 is negative 9. To keep this equivalent to that, if I subtract 9 arbitrarily, I also have to add 9. So 2 plus 9 is 11, and then 3x minus 3. If you distribute that and add 9, that would be equivalent to what we started with. So that gets our center correct, which we want to do first. Then we need a minus. We don't need a plus, we need a minus. Well, a plus is 2 minuses. A plus can be written as minus a negative. So now we have a constant minus something. 1 minus something. So now that we have our minus there and our center correct, we just have to make this a 1. Well, how do we make it a 1? We divide it by 11. But if we divide that by 11, we have to divide that by 11. If we divide the bottom by 11, we have to divide the top by 11. So we get 4 over 11 over 1 minus negative 3 times x minus 3 over 11. So a is the top, r is what we're subtracting from 1. So the series, our power series, goes from 0 to infinity. A is 4 over 11. R negative 3 times x minus 3 over 11, and r is raised to the n power. So that's our power series. That can be rewritten a little bit because this is a coefficient we could put out front, but that's our power series. Now, what about our interval of convergence? Well, our power series, our geometric series converges when the absolute value of r is less than 1. So if we take the absolute value of r, make that less than 1, we need to put this in x minus c absolute value is less than r. So get rid of the 11 on bottom. So multiply both sides by 11. We need to get rid of this minus 3 on top. So we're going to divide, but we're going to divide by positive 3. Why positive 3? Because that negative 3 is on the inside of an absolute value. Well, if we have a product and a quotient, we can take the absolute value of each piece. Absolute value of 11 is 11, so to make it go away, we just multiply the top by 11. To make the negative 3 go away, we divide by the absolute value of negative 3, which is really 3. We'll divide the other side by 3. So the 11s cancel, the 3s cancel, so we're left with the absolute value of x minus 3 is less than 11 thirds. So our center is at 3, which is where we were told for it to be. And then we go to the right 11 thirds. And then we go to the left 11 thirds. 3 is 9 thirds. So if we add 11 thirds, 9 thirds plus 11 thirds would be 20 thirds. 9 thirds minus 11 thirds would be negative 2 thirds. So our interval goes from negative 2 thirds to 20 thirds. The only question is going to be, do we include the edges or do we not include the edges? And recall the way we check that is we put in our series, we put in place of x, we put a negative 2 thirds, and we check to see is this going to converge or diverge. And then we put a 20 thirds in for x, and we check to see is that going to converge or diverge. For time's sake, we're not going to do each of those for right now, but it turns out, like the last one we did, the left and the right side, neither one converge, so it's only the stuff on the inside. Some of that goes to the fact that this one is geometric. On the ones we did in the past where we checked the edges, we were using the ratio test. The ratio test was not determinate at the ratio equals to 1. So on the where equaled, we couldn't determine. For the geometric series converged if absolute value of r is strictly less than 1. If it's greater than or equal to 1, it diverged. So where it's less than 1, that's on the inside of that. So that's our interval of convergence. Interval of convergence. Okay, if we take a look at this one, we have a little issue. The one we did in the previous problem, we had a linear denominator. And it was easier to take a linear denominator and make it look like this because r is linear to the first power. So I could try different things. But notice that this function, that this fraction, has a denominator that will factor. It factors to x plus 8, x minus 1 on bottom. If you do partial fraction decomposition, you're going to get 8 over x plus 8 minus 1 over x minus 1. So just to save you a little bit of time there, I went ahead and did that. But you get 8 over x plus 8 minus 1 over x minus 1. And I said minus, is actually plus there, not minus. So our original function is equal to 8 over x plus 8 plus 1 over x minus 1. So we want to find a series that's going to add up to that. What is a series that we could add that up to that? Or how about two series that add up to that? One series that adds up to this plus one series that adds up to that. We want it to be centered at 0. So these, we're going to try to use a geometric series, and we want to find out what would A need to be and R need to be for that, for our geometric series to add up to that, and then what would A and R need to be so that our geometric series adds up to this. So on bottom, for the first one, let's move the 8 out front. Let's rewrite that as 8 minus negative x, and then divide top and bottom by 8. If we divide top and bottom by 8, we'll get 1 over 1 minus negative x over 8. 8 divided by 8, 8 divided by 8, and that divided by 8. So that's A, and that's 1 minus R. So that's for the first series. So we get the series is n equals 0 to infinity of A, which is 1, times R to the n power. And now for the other one, let's rearrange this. If we put the 1 first and then the x, we actually have a negative 1. So to multiply top and bottom by negative 1, that would give us a negative 1 on top. If we distribute a negative 1 on bottom, we would get 1 minus x. Well, that's the form we need. 1 minus x. Since it's centered at 0, we don't have anything subtracted from x. We don't have anything subtracted directly from x. So in this case, A is negative 1, R is x. So for this series, we get negative 1 times R to the n. So our total is going to be the sum from n equals 0 to infinity, negative x over 8 to the n, plus the sum from 0 to infinity of negative 1 times x to the n. Since we're adding to the same thing, we can put these together. Think about this as being an infinite number of terms, and this being an infinite number of terms. We can combine those into a single series because our index matches where it starts, they match. So we could call this negative x over 8 to the n plus negative 1 times x to the n. And then we should be able to simplify that. So let's rewrite what's on the inside a little bit. Let's take this negative to the denominator, and then let's raise top and bottom to the n power. So that's x to the n on top, negative 8 to the n on bottom. Plus or minus, we can call this minus 1 x to the n. Notice each of those have an x to the n in them. So x to the n is a common factor. We can pull that out. If we take an x to the n out of the second term, we're left with just a 1. If we take an x to the n out of the first term, we're left with a 1 on top, negative 8 to the n on bottom. So this is our series that is equivalent to the fraction we began with. This is a power series centered at 0, such that our series is equivalent to our original rational function. Okay, so we have our series. In that format, that's not exactly geometric, or a standard geometric here, a to the times r to the n. Because this part is changing. As n changes, this coefficient changes. So in order to determine our interval of convergence, let's look at it in this format. In order for this to converge, the first one is going to have to converge. Negative x over 8 to the n, that's going to have to converge. And then that's going to also have to converge. So for the first one, r is negative x over 8. So we need the absolute value of r to be less than 1. And also we need the absolute value of x to be less than 1. R is x on that one. So say that again. R is negative x over 8 here. R is x here. And for a geometric to converge, the absolute value of r has to be less than 1. So this one and this one both have to converge, or otherwise, if only one of them converges, if the other one diverges, then the whole thing diverges. If you add something to infinity, infinity takes over. So if one of these is divergent, that one takes over. So for the first one, we can drop the negative because it's inside the absolute value, multiply by 8, and we get that. And we also get that. So we're looking for and, that's the intersection of this interval and this interval. They're both centered at 0. This one goes to the left and to the right 8. This one only goes to the left and to the right 1. So what will they have in common? They'll have in common the stuff that's in the middle. This one doesn't go beyond that, so this one doesn't have that stuff from 1 to 8 or the stuff from negative 1 to negative 8. This one includes that, and that one includes that. So our interval of convergence is actually going to be negative 1 to 1. Everything, this one converges on that interval, this one also converges on that interval. One of these, particularly this one, converges other places, but this one doesn't. So the interval of convergence has to be where they both converge. So that's there.